Hello dear learner, welcome back to the Zoom Chemistry Hub. Today in this lecture we will discuss most important and exam oriented topic from the chapter chemical equilibrium, that is law of mass action with its derivations. So first we discuss the statement of law of mass action. This law states that the rate or speed of a chemical reaction is directly proportional to the product of the molar concentration of reactant substance. So this means that the rate or speed of a chemical reaction is directly proportional to the product of the molar concentration of reacting substance. A reactant substance may be the reactant in the forward reaction. Reactant substance may be in the forward reaction, that is reactant, and in the backward reaction, that is product. So these are two reactant substances in a reversible chemical reaction. When the forward reaction goes on, the reactant substance are reactant, and when the reverse reaction is proceed, the backward reaction, in the backward reaction the amount of product or the product amount is the reacting substance. Now we consider an example of a reversible reaction, that is, in this reaction A and B are the reactant and C and D are the product in a reversible chemical reaction. Now we derive the equilibrium constant expression. First we know that we divide this reaction into 4 steps. In the first step, when we write the rate of forward reaction, so according to the reversible reaction, the rate of forward reaction is directly proportional to the product of the concentration of the reactant. So here we can see that AB are the reactant, and these brackets are denote the concentration of these two reactants. So the rate of forward reaction is directly proportional to the concentration of the reactant A and B. And when we remove this proportionality sign, then RF is equal to its constant, that is constant into concentration of A and the concentration of B. This is the first equation. And we know that the rate of reverse reaction in the second steps, first steps and in the second step, the rate of reverse reaction, we denote reverse reaction in small r, and capital R denote the rate. So the rate of reverse reaction is directly proportional to the product of the concentration of the product, that is C and D. And if we remove this proportionality sign, it makes rate of reverse reaction is equal to the constant into concentration of C and the concentration of D. This is the equation 2. Now according to the reversible chemical reaction, the rate of forward reactions are equal to the rate of reverse reaction. So we write here rate of forward reaction. Rate of forward reaction is equal to the rate of reverse reaction. So we write the value of forward reaction and the rate of reverse reaction. That is the value of rate of forward reaction is K forward into the concentration of A and the concentration of B is equal to, and the value of rate of reverse reaction is the constant into rate of reverse reaction is the concentration of C and the concentration of D. Next, now we will shift Kr into the left side and concentration of the reactant into the right side. Then we make a new equation, that is Kf. When we shift Kr into the left side, it comes as a denominator, that is Kr is equal to concentration of C into concentration of D. And when we shift the A and B to the right side, it goes as a denominator. So concentration of A and concentration of B. Now we know that Kf and Kr Kf divided by Kr is equal to Kc. So we write Kc instead of Kf divided by Kr, which is the equilibrium constant. Kc is the equilibrium constant. So Kc is equal to concentration of C into concentration of D divided by concentration of A and the concentration of B. So this is the last and final steps for the derivation of equilibrium constant expression, and this is the ratio. So we can say that Kc is the ratio of the concentration of the product of the concentration divided by the concentration of the product of the reactant. So that's for all today. If you have any queries, please write me in my comment box, and if you like this video, please like, subscribe and share with your friends and fellows so we can grow each other.